for all x belongs to real number. Option B, x equals to 0. Option C, x is a non-zero real number. Or option D, x equals to -1 and 1. You can write this set as R star also. They hold same meaning. Now, we will solve this question, but before that, let's discuss about mod function. Okay, say fx equals to mod x. This is our modulus function. What is the property? What are the property of this function? This function's domain is real number, that we can choose x as any real number, but its range is the positive real number. So how it is defined? It is defined as x when x is greater equals to 0, 0 when x is equals to 0, and minus x when x is less than 0. Let's take an example. First, we will take a positive real number. First, we will discuss this case. Say 5. So we can see that mod 5, as you all know, it is 5. Now the second case, it is trivial. If we take 0, it will give us 0. Mod 0 is 0. Now, if we take -1, we are discussing this case. In this case, we will get output minus x. Modulus of -1 is 1. You can see that this -1 can be written as minus of -1. So here x is -1 and our output is minus x. So that's the definition of mod x. Now let's move to our problem. So here our function is fx is equals to x divided by mod x for x less than 0 and -1 for x greater equals to 0. Now, as we saw earlier that if x is less than 0, mod x is equals to minus x. So we can rewrite this as minus x minus 1 . So it will give us -1 for x less than 0 and -1 for x greater equal to 0. So we can see this function is nothing but fx equals to -1 for all x belongs to R. So this is a constant function. Clearly, this is a constant function. And if we draw the graph of a constant function like this, let's take this function fx equals to -1. It means that if we put any kind of value in x, it will give -1. So if we draw the graph, suppose that is our -1 point. So this is our function and so on. So this is a constant function, and we know that constant functions are continuous, as you can see in the graph. So our correct option will be for x belongs to R, for all x belongs to R. Option A. Now we will move to the next problem. That's a good problem. Question number 4. Find the number of points of discontinuity of f defined by fx is equals to mod of x minus mod of x plus 1. So this is our given function. Now you can see this is a problem of 2 marks. It is looking quite difficult, but it is not. If you try to solve it computationally, you will feel the toughness, but you can solve it in graphically also, and the graphical method is also valid, and that is also easy. So for graph, we have to define the function carefully. So let's define the function fx equals to mod x minus x plus 1. Now you can see clearly, if we take x less than minus 1, then x is negative. So whenever x is negative, mod x always gives minus x, and this x plus 1, this is also negative if x is less than minus 1. Hence this modulus will also give the negative value. So we can write this as x plus 1. Then if we take x as minus 1 to 0, then in this range x is also negative, so this mod x will return minus x, but this x plus 1 will give a positive value. You can see clearly, you take any real number in this range and you will get a positive value. So this modulus will give just x plus 1. And if we take x totally positive, then this modulus will also give a positive number. This modulus will also give a positive number. So our function is, there x and x will be cancelled out. So here is 1 for x less than minus 1. Here minus 2x minus 1 less or equals to 1, 0, minus 1 whenever x is greater or equals to 0. Now this is our function. We can easily draw the graph of the function now. So let's draw. Okay. So here, whenever x is less than minus 1, the function is 1. So let's take this as 1. So whenever x is less than minus 1, the function is 1. So this part done. Then when the function x lies between minus 1 to 0, so from this to this, the function became, suppose y equals to fx minus 2x minus 1. For drawing the graph, we will use slope-intercept form of a straight line. This is also learned in class 11. Y plus 2x equals to minus 1. Then I can write this as x divided by minus half plus y divided by minus 1 is equals to 1. So this line, this is the equation of straight line. This will cut the x-axis at the point minus half comma 0 and will cut the y-axis at the point 0 comma minus 1. So suppose that is our minus half comma 0 and this is our 0 comma minus 1. Then whenever function is positive, the value of the x is positive, then the function's value is minus 1. We got earlier that this is 0 comma minus 1. So this is our function. As you can see, there is no cut in the domain. The function is totally continuous. So after drawing this graph, you can straight write that clearly fx is continuous for all x belongs to R. So this problem is quite important for your boards and also for the competitive exam, because this kind of functions need a little bit of intelligence, because so many of students will do it using computational method that will take a long time. So you can solve it graphically. Now we will move to question number 5. So our function is fx is equals to x plus sine x divided by sine a plus 1 x whenever x lies between minus pi and 0, and 2 e to the power sine bx minus 1 divided by bx whenever x is positive, and 2 whenever x is 0. It is given that f is continuous at x equals to 0. We have to determine the values of a and b. Okay, so same logic we already used at question number, let me see, yes, question number 2. So now question number 5 here. So what was the logic? That limit at 0 must be equal to f0 as it is continuous. Now f0 is 2. And what is our limit? The criteria of existence a limit is left hand limit is equals to right hand limit. LHL must be equals to RHL. After that, our limit will exist. Now for this problem, here we are given that x less than 0 and x greater than 0, two different values. So we have to use this LHL and RHL concept to determine the limit value. Okay. So let's compute the left hand limit first. Left hand limit x tends to, for left hand limit we always put this minus sign after the limiting point. Fx, what is our fx? See, as it is left hand limit, the points are reaching towards 0, tending to 0 from the left hand side. It means the negative ones. So we will take this value of fx. So our fx is x plus sine x sine a plus 1x is equals to, now here we have sine a plus 1x. We can multiply a plus 1x both in numerator and denominator like this: x plus sine x divided by a plus 1x into a plus 1x divided by sine a plus 1x. Now we already know that this value will become 1, as we already know that limit x tends to 0, sine x by x is 1. So this value will become limit x tends to 0, x plus sine x divided by a plus 1 x. Now I can rewrite this as it is a constant term. I can take it outside the limit. Minus 0, and I will divide this x with both of them. It will become 1 plus sine x by sine x. Now, as 1 is constant, so it will return also a constant value 1, and this sine x by x limit at 0 is 1. So it is 2 by a plus 1. Now this is our left hand limit. Now as this function is continuous, its left hand limit, right hand limit is equal. So limit exists, and this is also equal to the right hand limit and left hand limit, and the value of the function at 0. So we can put 2 equals to 2 by a plus 1 using this. So from this we can determine the value of a. Cancel a plus 1. So a is 0. This is our value of a. Now using right hand limit, I can compute the value of b. So what is our right hand limit? So for right hand limit, the points tending to 0 are from the right side. That means they are the positive values of x. So for that, our function is this. So we will compute the right hand limit now. RHL. Sorry, this is bx. Only bx. Sorry. This is bx. Now I can write this as limit x tends to 0 plus, as 2 is a constant, I can take it out, 2 e to the power sine bx minus 1 divided by sine bx. I will explain why I am taking this sine bx by bx. Now we have already learned at class 11 that limit x tends to 0, e to the power ax minus 1 divided by ax is equals to 1. Okay, so here, sorry, e to the power yeah, this one. Now, so from this value will return 1, and again the sine bx by bx will also return 1 using this. So it will give us 2, that is equals to the function defined at that point f0, that is also 2. So it is clear that our right hand limit is not depending on the value of b. So we can put anything in the place of b. So our final answer will be that a is equals to 0, and for any b belongs to real number, the function will be continuous at x equals to 0. It is clear? Next. So our next problem is quite similar. Determine the value of P and Q. I'm not writing the full question. Determine the values of P and Q where fx is equals to 1 minus sine cube x divided by 3 cos square x if x is less than pi by 2. P whenever x is equals to pi by 2, and Q into 1 minus sine x divided by pi minus 2x whole square whenever x is greater than pi by 2. It is given that f is continuous at x equals to pi by 2. Now here also for x less than pi by 2 and x greater than pi by 2, we have to compute the left hand limit and right hand limit. Then we will equate it with p. As the function is continuous at pi by 2, we can write it LHL equals to RHL, of course at pi by 2, x equals to pi by 2 is equals to the limit x tends to pi by 2 fx is equals to f at pi by 2. We can see it clearly that f is defined at pi by 2, that the value is p is equals to p. Now let's compute the LHL first. For the LHL, left hand limit now we can write it as x equals to pi by 2 minus h. Then as x tends to pi by 2, h tends to 0. So I can replace it h tends to 0, 1 minus sine cube pi by 2 minus h divided by 3 cos square pi by 2 minus h. Now this is limit h tends to 0, 1 minus cos cube h by 3 sine square h, the basic trigonometry. Then I can expand this 1 minus cos cube h of the formula of a cube minus b cube, that 1 minus cos cube h, cos h into 1 plus cos h plus cos square h divided by 3 1 minus cos square h. We're cancelling them. I can take the constant value outside the limit. Then you can easily put the value 0 here, and we will get 1 plus 1 plus 1, as cos 0 is 1, 1 plus 1, so that is half. So this is our LHL. So we can get from there, from using 1, our P is half. Now we will calculate the RHL. For RHL, now putting the values. What is the function? Q1 minus sin x, pi minus 2x squared. Okay. Q1 minus the value will give Q1 minus cos h to 2 pi minus 2h whole square. Now putting the value 0 in the place of h, we will get no, we can't put it now. Let's I guess that's not correct. That is okay. Yeah, yeah. This is pi and pi will cancel out. So here I am getting q into 2 sine square h by 2 divided by 4 h square. Now taking the value q out, as it is a constant, h tends to 0, 2 and 4 cancels as 2. I can write it as sine h by 2 whole square. And now as I'm taking here h square by 4, we have to balance it by I think, yes, we have to divide it by 8. So then this value will give us the 1. So we will get q by 8. Now this q by 8 is equals to half, as we have seen earlier from the definition. So q is equals to 4. So our p is half and q is 4. This is our final answer. Now next question. Next question. We have to find the value of k for fx is equals to kx squared for x less than 2. Now this is continuous function at is continuous at x equals to 2. We have to find the value of k. Now using the definition, limit x tends to 2, fx is equals to f at 2. Now this is a notable point that if you get a polynomial, you have 3x plus 5 or kx squared, these two are polynomial function. This polynomial function limits always exist. This is also continuous and they are also differentiable. So if we use the value at the function with f2, here we can see x is greater or equal to 2. So at x equals to 2, the function will be 3 into 2 plus 5, that is 6 into 5, it's 6 plus 5 is 11. So that's the value of the function at 2. Now we have to evaluate the function's left hand limit and right hand limit, and we will equate it with 11 and we will get our required answer. Now let's compute left hand limit. Limit h tends to 0, f2 minus h. We are just considering that x equals to 2 minus h, whenever x tends to 2 minus h will be tends to 0. Now here we are applying the left hand limit. So all the points which are tending to 2 are in the left hand side. So we will use this value of the function. Limit h tends to 0, k, and x at place of x we will use 2 minus h whole square, that is h tends to 0, 4 minus 4h plus h square. Now as it is a polynomial, we can easily put h equals to 0 here and we will get 4k. Now this 4k is equals to 11. There is no need to evaluate the right hand limit because it is given that the function is continuous. So just equate it with f2 and we will get the answer k equals to 11 by 4. That's quite easy one. Now question number 8. Here the function is given 1 minus cos 4x divided by x square, x less than 0, a x equals to 0, and root x divided by root over 16 plus root x minus 4 whenever x is greater than 0. Now f is continuous, at x equals to 0 we have to find a. From the chapter continuity we will face a similar kind of question actually. So now let's evaluate. It is given that the function is defined at 0, that the value is a. Now we have to calculate the left hand and right hand limit. So for left hand limit x tends to, our function will be 1 minus cos 4x divided by x square, that is equals to 2 sine square 2x x square. Let's take into 4 into sine square 2x divided by 4x square. Now I can write this taking the scalar out. Limit x tends to 0 minus sine of 2x divided by 2x whole square. That is nothing but 1, and 1 into 8 is 8. So this is our left hand limit. Now as it is our left hand limit and it is given that function is continuous, there is no need to find the right hand limit. We can easily equate it with this and we will get the value of a is 8. Now we are moving forward to question number 9. Here the function is defined if x equals to sine a plus 1 x plus 2 sine x divided by x less than 0 to x equals to 0 root over 1 plus bx minus 1 divided by x greater than 0 is continuous at x equals to 0. Similar question, we have to find a and b. So first we can see the function is defined at 0, the value is 2. Now let's move to the left hand limit and right hand limit. So for left hand limit, if x equals to, for left hand limit we will use the values tending to 0 from left hand side. So this one, x tends to minus 1 sine a plus 1x plus 2 sine x divided by x. Now by definition of limit we can replace it by h tends to 0 sine a plus 1, replace h with 0 minus h plus 2 sine 0 minus h divided by 0 minus h. So it will give us minus of sine a plus 1h. As you are well aware about this property of sine, you can write this. This is 2 sine h divided by minus h. We will take common the minus and we will get sine h plus 2 sine h now I can write this as a plus 1 plus limit from this I will get 1 into a plus 1, so a plus 1 plus 2, so here I am getting a plus 3. Now this is equals to f0, right? So what is the value of f0? F0 is 2, so my a is minus 1, sorry, not 1, a is minus 1. Now using the right hand limit, I will evaluate the value of b. Let's calculate the right hand limit. We have to rationalize this by multiplying 1 plus root over 1 plus bx plus 1 with numerator and denominator also. So root over 1 plus bx plus 1 x into 1 plus bx plus 1. So it will give us 1 plus bx a square minus b square, so that is root over 1 plus bx squared, that is 1 plus bx, and minus 1 square is 1, and x into 1 plus bx plus 1. So 1 is cancelling out, x and x are cancelling out, so I can put x equals to 0 here, and it will give me b by 2. Okay, it will give me b by 2, and that is also equals to f0. And what is f0? F0 is 2, so my b is 4. So from this we can easily evaluate that a is minus 1 and b is 4. Okay, that's our question, and that's the solution. So the last question today. Let me choose a question first. Okay, so that's the question. Verify that whether the function fx equals to x sine 1 by x, or x not equals to 0, and at 0 it is defined as 0, is continuous at x equals to 0 or not. Now for you not have to solve it, but if you get this question in your subjective section, then you have to solve it. But I am writing a note for you for your reference, that if this kind of function like fx equals to x alpha sine 1 by x not equals to 0, 0. And in question, if it is asked that whether it is continuous or differentiable, you will always check the value of alpha. If alpha is greater equals to 0, f is continuous at 0, and alpha is greater than 0, not equal to, strictly greater than 0, then f is differentiable at 0. Okay. So from this note, you can easily say that this is continuous function, but this question is from a subjective section, so we have to solve it. Okay. So it is clear that the function is defined at 0, f0 is 0. Now we just have to show that LHL is equals to RHL is equals to f0, right? So our LHL is left hand limit is equals to limit x tends to 0 minus x sine 1 by x. Now limit, from the definition of left hand limit, I can replace it by 0 minus h sine 1 by 0 minus h. So it is limit h tends to 0 minus h sine of minus 1 by h, that is limit h tends to 0 h sine 1 by h, and this is a very well known limit to us that its value is 0. Okay, now we just have to compute the right hand limit. This is equals to f0. Now we are only concerned with right hand limit. So for right hand limit, sorry, that is h tends to 0. Limit h tends to 0, h, and this is also 0. This is also equals to f0. So this condition is satisfied. LHL is equals to RHL. It means limit x tends to 0, fx exists, and this is equals to f0. So the function is continuous at x equals to 0. Now just a quick revision note I'm sharing with you about the continuity. So for just a revised notes, which points you have to look after for this chapter. First of all, to check continuity. To check the continuity, what is the condition? Left hand limit equals to right hand limit equals to, it's kind of obvious, if LHL equals to RHL, then it is equals to the limit value. Fx equals to Fc. It implies f is continuous at x equals to c. Any one condition from this, if broken, then the function is discontinuous at that point. Next, some useful function which are trivially continuous, we don't need to check it whether it is continuous and not. These are already continuous function. Then the examples are, first of all, constant function. What is the constant function? Fx equals to c. You can see from their graph, if this is fx equals to c, then the graph is like this, parallel to x-axis, and this is clearly continuous. Second is polynomial function. Third is trigonometric functions. Fourth, exponential function. Modulus function. And the useful limits. Useful limits. Number 1, limit x tends to a, x to the power n minus a to the power n divided by x minus a is equals to n a n minus 1 to limit x tends to 0 as 1, x tends to 0, tan x by x equals to 1. Fourth one, limit x tends to 0, e to the power x minus 1 by x is equals to 1. Fifth, limit x tends to infinity, 1 by x to the power p is equals to 0 whenever p is positive. Number 6, one plus x divided by x equals to 1. X tends to 0, a to the power x minus 1 divided by x log a. One plus x one by x equals to e. And that's all. These all limits we are already aware in our class 11, but we will use it to solve our problems on continuity in class 12 exams. So best of luck for your exams. That's all for today.